Okay, here we have a circle question. The first thing we have to do is, as it tells us, complete the square on things here to arrive with a standard equation of the circle that looks like this. Now I strongly recommend you look at your x's separately, you look at your y's separately, you get an expression for the x's completed the square form and for y's in completed square form, and you put those two things added together back on one side of the equation. You don't forget the equals 11, and then you simplify your constants and get your equation in that form. Should be 3 easy marks. Whatever you do, at least come up with some equation in this form, because these marks here are probably followed through and they just come from reading off the coordinates of the centre of the circle and writing down the radius of the circle, which is direct from the equation you've got there. Finally, we've got the point O, which is the origin, we've got to find the length of CO, so that's the distance between points. That's your first method from chapter 3. And then in dotted 2 we've got to decide whether the point O lies inside or outside the circle, giving a reason for your answer. Now when you've got questions about points being inside or outside the circles, I don't recommend trying to use the equation of the circle directly. Do what they're steering you towards here. Find the distance of the given point from the centre of the circle. You know what the centre of the circle is from B dot E1. You've worked out how far O is from the centre, and then you need to make a clear comparison of that with the radius of the circle. If the distance is bigger than the radius, then you're outside, and if it's less, you're inside. And if it's equal to the radius, you're actually on the circle.